during 2017 to 20. He also served as a visiting professor, Civil Engineering Department, IIT Roorkee, during 2020 to 2025. Currently, he is a visiting professor at IIT Gandhinagar. Sir, I request you to for your lecture. Please, over to you, sir.
Hello, am I audible?
Yes, sir.
Okay, thank you, Pallavi. So I'll talk about stormwater management, and this will be sort of a broad lecture covering the various aspects, with some of them are particularly relevant to India. So let me share my screen. Is my screen visible? Hello? Hello?
Yes, sir.
Is it visible, my presentation? Hello?
Yes, sir.
Okay, good friends. So uh, I'll be talking about stormwater management with a broad perspective from India. This here is a slide which shows the causes of urban flooding, and here 5 causes of flooding have been identified. Uh, Okay, so these are, first of all, as you see, number 1 marked in the channel network. So this refers to lack of drainage infrastructure. In a particular case, maybe all the areas are not covered by a drainage network, and so in those places might suffer submergence. Then we have this number 2. So number 2 refers to backup due to elevated downstream levels. So here there is a channel or a stormwater drain which carries water, uh, but there is high water level near the downstream end, and that's why water is not able to pass through, leading to flooding. Then there can be flooding in low-lying areas. This area doesn't have a natural drainage at every elevation. So uh, at places, this situation may arise, leading to submergence. Then inundation might be caused by river or high river or stream water level. So again, here the water level in the stream may be high, leading to submergence. And then there may be a situation where a drainage system is blocked. If the drainage system is blocked, then water may not be able to move, leading to again flooding. Then there can be flooding due to high rainfall, and 3 cases are discussed here. In the first case, the drainage system is overwhelmed by excessive runoff, leading to water logging and high overland flow. So the rainfall may be very intense, which leads to high flow. Then there may be short duration, high intensity rainfall. Typically, a rainfall of 20 millimeter or more intensity per hour in places like Roorkee, that causes inundation. In the IIT campus also we have seen that if the rainfall intensity is more than 20 millimeter per hour, then there are places where flooding can be expected. Then if the lower intensity rainfall, and lower means something about 10 millimeter per hour, so rainfall at that intensity continues over a longer period of time, then it also leads to substantial amount of water on the ground and submergence. So these are 3 cases due to pluvial flooding, and 5 cases we saw due to deficiency in drainage system or due to topographic regions. Now, this slide here explains the broad reason why flooding takes place in an area. So consider this area, which is in natural condition where maybe some farming is carried out, there is very little or no built-up area. So this vertical downward arrow represents rainfall, which is taking place at some rate. Water is infiltrating in the ground, represented by downward pointing red arrow, and lateral pointing horizontal blue arrow represents surface runoff. So rainfall is divided into infiltration and surface runoff, and this water is carried. It doesn't cause any submergence. But suppose due to changes in land use, houses are constructed or a colony is established in this area. So what changes would be expected? Let's consider a case when rainfall is at the same rate, but because of concrete or because of road, because of paved surface, infiltration capacity is now considerably reduced, and almost no water is allowed to infiltrate it because of this region. So this leads to higher amount of generation of surface runoff, and this surface runoff rapidly moves over the paved area, but then it encounters some obstruction due to boundary wall and other reasons. So although the surface runoff is being generated at higher rate, it is not able to rapidly clear this place, and as a result, submergence may occur, which we call urban flooding. So change in land use and the properties of the ground are resulting in urban flooding. In addition to this, due to climate change and other regions, the rainfall intensity may increase. So against some figure at which rainfall was falling in the earlier case, now the rainfall is more intense, and that contributes to additional flooding. So these are the causes of urban flooding. Now, many studies and experience shows that these type of floodings cannot be eliminated, but of course we can manage them to a large degree depending upon the means employed. Just to give you an idea how rapidly urbanization is taking place in our country. So this here is a slide which shows the urban area in Delhi in various times. So right now what you see is the urban expansion which corresponds to 1994. So the light blue area shows the extent of, sorry, this red area shows the extent of urban area, which was about 273 square kilometer. This urbanization increased, and in 2004, about 426 square kilometer of the area was urbanized in Delhi. In 2014, this figure further increased, and we have a number of about 623 square kilometer. And then in recent times, the urban area is exceeding 700 square kilometer. So from 273 square kilometer in 1994, currently we have more than 700 square kilometer of the urbanized area in Delhi. And then in addition to this, there is considerable paved area surrounding the Delhi in the national capital region. Similar is the picture of many other cities in India. For example, here we have this picture of Bangalore city, urbanization as it existed in 1973. It covered about 55 square kilometer. You see some scattered red patches showing the urban area. This area increased to 258 square kilometer in 2002, then 550 square kilometer in 2014, and currently the urban area in Bangalore is about 741 square kilometer. Now, one consequence of this urban expansion was that many of these ponds which existed earlier have disappeared, and people have constructed houses or residences or office space in this place. So Bangalore is another city, and by and large, same is the picture in many other cities in India. So in a case of urban flooding, as we saw in the past also, a very crucial input or role is played by rainfall. In fact, rainfall intensity is very important in many hydrological climatic studies and urban flooding, and it is necessary to understand and to know how the rainfall intensities are changing across the country, how they have changed in the past and what is likely to be the picture in the future. So a few slides will show the trends in rainfall intensity changes. In this slide, there are three graphs which show how the rainfall intensities have changed with time. This is a spatial variance of annual maximum rainfall intensity. And there was a very small rising trend in the period up to 1950. But after 1950, due to several reasons, the rainfall intensity trend line is having a very high slope, which shows that with time, the intensities are increasing. This figure shows the variability of maximum rainfall intensity across the different times. And here also we can see that along with time, the rainfall intensity variability is rising. Then the trend analysis has also been carried out showing the positive trend and negative trend across various grids. And in case of in India, a large number of grids are showing positive trends. Of course, a smaller number of grids are also showing a negative trend. But overall, if we see that the rainfall intensity would be showing a rising trend in many parts of the country. Not only rainfall, the temperature is also rising, and this figure shows uh, three pictures. So the first one, or the most leftmost picture, shows the maximum temperature trend across the country. Here the blue color shows increasing trend and red color shows no trend. So large part in the peninsular part of the country, in the northern part, as well as in northeastern part of the country is showing increasing trend. And some states in the northern part or western part of the country are showing no trend as far as maximum temperature is concerned. The variation of minimum trend is different. Minimum temperature trend is different. So here the gray color shows increasing trend. So minimum temperature is increasing in large part of the country. And there are some states, for example, Maharashtra, then Andhra Pradesh, Telangana, Odisha, etc., where the temperature doesn't show any positive rising trend. Coming to rainfall trend, overall picture for the country. So rainfall is decreasing over some states in North India, for example, Jammu and Kashmir, Uttar Pradesh, Bihar, and then some states in the Northeast. Then this red color shows no trend. So a large number of places are not showing any rising trend as far as annual rainfall is considered. But state of Rajasthan is showing increasing trend. So a mixture of trends is seen depending upon the variable that we are considering, and there is no consistent trend for all the variables in one place. Now, this particular figure shows the rainfall intensities in terms of daily rainfall for some meteorological subdivisions in India in the year 2024. So this green line shows the normal values of these daily rainfall intensities. But in actual, and this figure, please remember it's for the year 2024. So in actual, in the year 2024, in, for example, Konkan and Goa subdivision, there were instances where rainfall intensity exceeded 120 millimeter per day. And there are two instances where the limit of 120 was crossed. And then there are many instances where rainfall of the order of 100 millimeter per day was observed. Now, this data pertains to the entire meteorological subdivision and sort of it's an average value. So you can imagine that if average rainfall is so high, there would be places where the actual daily rainfall intensity would be much higher. Almost similar is the position for coastal Karnataka, but here the maximum value is 120, whereas the maximum value was 140 in the case of Konkan and Goa. So in coastal Karnataka, again, there are many events where rainfall intensity approached 80 millimeter per day or where it exceeded 80 millimeter per day and even 100 millimeter per day. And please remember, this is a very large area. And again, if the average values over a large area are of this high magnitude, there would be cases where the actual rainfall at a localized scale would be much intense. Similar is the case with Kerala and Maharashtra. So here also you can see that the rainfall intensity in one case is approaching 120 millimeter per day. And then there are cases where it is close to 90 millimeter per day or more than 60 millimeter per day. So many places in South India have received very intense rainfall as far as daily rainfall values are concerned in 2024. We have some more uh, uh, data. So these are some meteorological subdivisions: Gujarat, East Madhya Pradesh, and Uttarakhand. In Gujarat, the intensities were quite high for some times. For example, here it was 60 millimeter per hour or more. Same the case here. In East Madhya Pradesh, rainfall approaching 60 millimeter and higher were two instances. And in Uttarakhand, there were many cases where rainfall approached 40 millimeter per day or even higher. So all along in 2024 monsoon, rainfall intensity of the order of 40 millimeter to 120 millimeter per day were observed in many parts of the country. And you can also see that in all these cases, the normal curve is much lower than some of the values which were measured. 2025 monsoon is particularly bad in the sense that rainfall has been very intense, causing severe damage in various parts of the country. And this is a picture from IMD, which shows that the historical one-day rainfall in Silchar, it's a place in Assam, broke 132-year record on June 1st, 2025. So in 1893, rainfall of the order of 290 millimeter was observed, millimeter per day was observed. But in the year 2025, 415.8 millimeter of rainfall was recorded. So this was again a very high value. And this year we have severe damages reported from Himachal Pradesh, from Uttarakhand, from UP, recently from Darjeeling and many other places because of very intense rainfall. So rainfall intensities are increasing, that's the bottom line, and they will continue to probably increase in the future, and we have to be ready to manage these types of problems. Now, this here is a summary graph which shows the kind of flooding experienced in many cities in India. Notably, very high flooding was observed in Delhi. Mumbai is famous for urban flooding, Bangalore, Kochi, then Hyderabad, Bhubaneswar, Patna, and Guwahati. And some data about this flooding is given here. To give you more detail, a blown up image of same data is presented here, which shows the years corresponding to high urban flood in these identified cities. So again, Delhi has been experiencing very high floods in different years. Mumbai, Bangalore, Kochi, etc. There are some cities, particularly Guwahati, which have been facing urban flooding year after year. And if you see the data of past few decades, there are numerous instances when this city faces flooding. Here the flooding takes place due to pluvial reasons. So rainfall is very intense, which is not drained in time. And this city is located on the bank of Brahmaputra River. So river water also spills and causes flooding in the city. Similar is the case with Patna, which is located on the bank of Ganga River. And due to that river, flooding is caused. Mumbai is a coastal city where flooding occurs because of intense rainfall, and there are some small hills near the city which bring which contribute lot of water for flooding. And there are cases when the sea water level is very high when the rainfall is taking place, and that also limits the ability to discharge flood water in the sea, causing flooding. Kochi is also a coastal city. Bangalore is not a coastal city. Neither there is any major river here. But this city faces urban floods due to unwise development and due to encroachment. Now, this figure shows some of the notable urban floods in recent times. So the years when this flooding took place, for example, Delhi had big floods in 2002, 3, 9, 10, and 23. Guwahati had 2010, but Guwahati is notorious for recurrent floods. Ahmedabad faced major floods in 2000 year and then some scattered floods in this year as well as in last year. Then Surat flood 2006 because of a river called Tapi. Mumbai floods of 2005 because of intense rainfall in 2017. Kerala also received very intense rainfall in 18, and Chennai had a huge flooding in 2020. So these are some cases where the city and its residents had to face because of huge flooding. Now, this slide gives some regional details of the flooding. So Mumbai and Surat have faced flooding because of expansion of built up area. And this information says that the runoff increased by about 30 times, again because of unwise development and lot of urbanization, as well as the reason that the drainage network was not updated and it was probably not properly maintained. Bangalore is a highly vulnerable city due to urban flooding, highest in South India, as we saw just now. Delhi has faced urban flooding in many cases, as well as Kolkata. Now, again, more details are given here as to the major flood events in different years. For example, in 2024, North Bengal faced many flooding events. Darjeeling, Jalpaiguri, and Cooch Behar area faced floodings. Then in 2023, North India, Himachal Pradesh, Uttarakhand, Delhi, Punjab, and Haryana, these places faced flooding. Then in 2023, there was cyclonic flooding in Chennai and some other places in South India. 2022, Assam had big floods, and then 2022, Gujarat and Maharashtra also had big floods. Then other years when major flooding took place, 2021, 2020, 2019, and of course Kerala floods in 2018 is fresh in memory, partly because almost entire state of the flooding, state of Kerala flooded, and that was the rain event which came when their reservoirs were also full. Of course, these reservoirs had a small capacity, but because they were full, they could not help in any meaningful way in flood mitigation. Then in 2015, Chennai had a very big flooding. Almost the entire city was underwater, including the Chennai airport, and the airport remained shut because of flooding for several days. The railways were also not operational, and that caused a lot of difficulty in providing flood relief. Now, because of floodings, Delhi had urban flooding in 2024 and in 2025. In 2024, Yamuna water entered in the city in the areas which were adjacent to the river, and they caused flooding. Now, in India, we have an organization called Central Public Health and Environmental Engineering Organization, which has prepared a manual to suggest what kind of design floods or design rainfall should be used for constructing urban storm drainages. So, according to them, internal drainage of urban catchments may not be designed for peak flow for rare storm events, like 1 in 25 years or 1 in 50 years. We all know that as this period increases, so 1 in 25-year flood may have X magnitude, 1 in 50 years flood or rainfall may have Y magnitude, and Y would be greater than X. So as this number increases, the magnitude of the return period rainfall or return period flood will increase. So they say that these urban drainages should not be designed for extreme, very extreme events, because that would not be practically feasible. And they have also noted that whenever the precipitation exceeds the design return storm, there would be flooding. But it says that such flooding may have to be accepted in spite of once a while inconvenience. So the thing is that urban flooding cannot be eliminated, as we saw earlier. Only thing is we can hope to provide relief, and we can hope to provide reasonable protection. So these guideline divides the cities in two categories. Class 1 cities are the cities which have population more than 1 lakh, and other cities have population less than 1 lakh. For class 1 cities, the central business area and commercial area should have drainage with return designed for return period of once in 5 years. And for other cities, a smaller value or once in 2 years would be adopted. Same is the case for industrial areas and for urban residential areas. Then airports and other critical infrastructure, the infrastructure which are supposed to remain functional even when the rainfalls are high, these should be designed for a return period of once in 100 years in class 1 city and once in 50 years for other cities. So these guidelines say few things very clearly, that we cannot eliminate urban flooding. Some inconvenience may have to be accepted. Class 1 cities should be provided better drainage network or drainage network to drain out more water or higher rainfall intensity water, and other cities should be designed with a less capacity network. Okay. Now, many losses, of course, take place due to urban flooding, that we know. So we know that there are many instances in India. Let us also look at some success stories, and I will cover some out of the box and some very, emerging and very uh, interesting ideas to control flooding. But the global cities which have been able to control flooding by adopting various means include Philadelphia, New York, Toronto, Shenzhen, Los Angeles, then some cities in Brazil, some cities in Europe. Then, of course, Tokyo is noteworthy, as well as city of Austin and Copenhagen in Denmark. In terms of cities in India, two cities stand out, Indore and Coimbatore, which have been able to partially control flooding by adopting green storm water infrastructure. That means engineering solutions as well as solutions based on nature-based solutions. So let us look at now some, out of the box thinking in many parts of the different parts of the world. And I'll tell you 5-6 cases where people have built underground facilities or surface facilities to store flood water. Here you see a big reservoir built in Chicago in 2015. This is a reservoir with a capacity of 7.9 billion gallon. Incidentally, 1,000 gallons are about 3.8 cubic meter. So this reservoir is connected with Chicago's deep tunnel network. And during the time when substantial flooding is expected on the surface, water is diverted through this tunnel network to the reservoir. As a result, flooding is reduced on the surface, and after the rain storm has passed, this reservoir is emptied so that next flood can be managed. A noteworthy among all these efforts is a system implemented in Tokyo long ago, about 20 years ago. This is called Metropolitan Area Outer Underground Discharge Channel. And I was fortunate to visit this place in 2018 during a visit to Japan. So what they have done, this place used to be submerged frequently. So they constructed through vertical silos or vertical, you can say, columns, which were interconnected by tunnels. So whenever there is submergence or excess water on the surface, water is diverted to these silos, or and it can move from one of these silos to the other through these tunnels. As a result, flooding is eliminated on the surface, and after the rainstorm has passed, water is pumped out by means of huge pumps to a nearby river called Edo River, which can vacate these silos quite rapidly with a discharge capacity or capacity of 200 cubic meter of water per second. To give you an idea of the spatial extent, so some of these are up to 70 meter deep, and they cover a horizontal distance of 6.3 kilometers. So it's a huge system which operates quite well, and they have been able to control flooding in a particular part of Tokyo city as a result of this underground network of silos as well as tunnels. A similar or setup was created in the Brazilian city of Rio de Janeiro. This was the city where 2016 Olympics were held. And this city was notorious for urban flooding, and they didn't want this mess up during the Olympics. So to provide a solution for Olympics as well as subsequently, they again constructed 4 underground reservoirs as well as diversion tunnel. And here also, same as the case of Tokyo, during flooding events, the water is diverted through the reservoirs, and after flooding takes place, this water reservoirs are emptied, leading to control of urban flooding. In addition to these cases, the city of Copenhagen in Denmark, they are building a network of underground tunnels to manage heavy rainfalls and to prevent flooding. And these are part of a scheme to manage cloudburst events in the city of Copenhagen. And finally, one more example comes from Austin, Texas, where a flood tunnel has been constructed, which runs about 70 feet deep, 70 feet below the surface, from this place called Waterloo Park to Lady Bird Lake. And this tunnel is again used to divert flood waters from the surface to this lake so that the flooding in the city can be avoided. So, this type of ideas which were considered to be out of the box thinking at one time have been implemented in many cities across the world, and These are under implementation in many other cities. And I think it would be good to consider these options in case of India also. So here we can think of building these tunnels below the surface. We can also think of, building some reservoirs, for example, below the parks. Now, Delhi has a number of parks, and below some of these parks, reservoirs can be constructed if that area is receiving submergence, and excess water can be, diverted to these reservoirs. And after the rain event has passed, it can be pumped and diverted or drained to the river. So this type of schemes can be thought of in cities for India also. Now, in the past lecture also, you heard about this climate resilient development or green development using green techniques to manage urban flooding. So these techniques are also becoming very popular, and now there is emphasis that we should not build only gray infrastructure. We should build green infrastructure also, which is resilient to climate change. The climate change is making many places vulnerable. The intensities of rainfall are increasing. As a result, floods generated are increasing. And in such situations, the climate resilient development can be very helpful. And I'll again show you some examples where some cities of uh, other countries have adopted climate resilient development. In fact, in India also, as we know, these techniques are being practiced. So this here is an example from Norway where you can see these tram lines. Now, many years ago, all these areas were paved, but they realized that they should adopt some green techniques to manage urban flooding. So this area occupied by tram lines in different parts of the city here was unpaved, and now you have grass surface here. This grass surface helps in absorbing floods, leading to reduced depth of water on the surface. So this is an example from Norway, and similar techniques have been followed in Holland. In Holland also, they unpaved the areas close to tram tracks, and these areas now absorb floods. In addition, some innovative things have been planned or have been constructed in Norway, Holland. So here you see a playground in a business district. So all along there are offices, there are shops, and in the central area they have made a space for games where people play games. The level of this area is below the level of the surrounding space. So what happens during floods or during the times when there is intense rain, the water from the surrounding area gets accumulated in the playground, and there is minimum or very small depth of water in the surrounding area. And again, after the rainstorm is passed, this area is emptied. They have in fact implemented uh, one more innovative thing, that in this area along the edges they have provided these thin strips which are open, so water can quickly enter into the ground through these strips, and a small amount of water may have to be pumped out. So this is a very innovative application of common engineering tools, wherein a small area is provided, there is a depression, water can be accumulated, stored here, and then this water is allowed to quickly drain and join the subsurface space so that flooding is minimized. So then finally, to conclude, these are some thoughts on stormwater management in India. And the first thing is that stormwater can be best managed by adopting the reasons of this stormwater problems is because of natural reasons, high rainfall intensities, and anthropogenic cause, which include unwise development or development which is not keeping in line with the climate change and with the general climate of the area. So good management approach will involve both engineering infrastructure as well as green infrastructure. A number of steps would have to be taken to manage stormwater carefully. This will involve planning. There are many cities where we don't have very well planned urban drainage network. So planning has to be carried out considering various factors. Then these should be designed by following the guidelines. And I think in my view, because of climate change, the guidelines also need a revision. So design should be carried out according to updated guidelines. Then the infrastructure should be managed properly. In our case, many times, or it's very common to see the stormwater drainage network is choked. It's not able to carry water because it has been silted or there are plastic products, waste, and so on. Many of these drains have been encroached. People have constructed ramps over these, or they have constructed some other things which are prohibiting free movement of water. Then cities are expanding very fast, but our drainage networks are not able to keep pace with this expansion. So the drainage networks require both upgradation as well as expansion. And while designing the networks for the cities, we should account for climate change impacts on rainfall intensities. These green solutions, some of these things we have discussed in details, but these have to be all, explored and adopted. In addition to stormwater management, management of pollution and solid waste and sediment should also go hand in hand with stormwater management. So friends, that's all I had for this talk. Thank you.
Thank you so much, Professor Saraj Jain sir. Thank you for your valuable talk and informing us about the major urban floods in India and its rising concerns. Once again, we thank you for your valuable talk.